Hello and welcome to Legato short topic videos. These videos provide a quick look at various Legato features and functionality. This is the second of 4 videos on program flow control. All programs need to be able to decide to do certain things or not to do other things. These are condition statements. Basically, we say if a particular condition, then do something or things. There are also while and for, and you can have on a particular condition to do a variety of things. In addition, there are also declared or defined conditionals that allow you to not interpret a particular area of a program. Those are done more along the lines of some particular thing is not defined, don't even consider this part of the program, and that's covered in a different video. When we have a condition defined, in the case of true or else false, I'm going to want to run certain statements. Those are contained within a block and defined by braces. The open brace says, go do all these things, and the closed brace says, I'm done with this set of things to do if the condition's true or if the condition's false. One of the most fundamental condition statements in almost every language is the if statement. Basically, the if tests a particular condition and then executes a block immediately after that statement. So it evaluates an expression. If that expression is 0 or false, it will not execute that block. If it's 1 or non-zero or true, it then executes that particular block. The opposite, or the other side of that, is the else statement, which is paired with the if, that says, hey, if this was false, then go and do this alternate scenario. As a programmer, you can actually chain the if-else series of test operations to do a number of different things based on various conditions. It's important to note that within Legato version 1, there is no if-else. You simply do an else statement with a block, with another if, and a series after that, so you'll have successive blocks contained within each other. So let's take a look at a basic example of the if statement. In this particular scenario, I'm loading a table up with attributes, and then I'm going to test that attribute. To return the variable RC, I can say RC is greater than 0. So that's my condition. I will then execute that block. If that happens to fail, I'll then go to the else, if there is an else. You do not have to have else statements, but you do have to have this particular block. Now, these can also get to be rather complicated. This is a full expression that can be put in here. I could load the in-string data into this group. I can also have logical ands and ors to say if this particular condition and this particular condition or this particular condition are true, then execute that particular data. When you have a complex expression that has multiple items in it, it's good to group the items within parentheses to help the precedence of what's being executed first. If in doubt, when you're having problems, break apart that particular condition to make sure that you actually have things working the way you think they work. And then finally, remember that the expression always evaluates to a Boolean true or false, and non-zero or 0. Even in the case of strings, if I say a string variable equals house, that's going to evaluate again to true or false. If you say string, just put a value in there in the string, it's going to look at that particular string and say, what is that if I looked at it as a number? And if it evaluates to a non-zero value, then it'll be considered true. A variation on the if statement is the switch statement, and basically it will take a value and test it against a series of cases. It provides an easy way to organize selective action, and there's also a default where there's a place to go when everything else fails, in case there's no matches. Also, cases will fall through to the next, which can be useful at times where the if-else type expression would not let you do that type of a thing. So the switch has a number of keywords. The most obvious is the switch statement or the switch keyword, and you'll have an expression, and that will open a particular condition. Switches always open a block of test conditions. Those test conditions then have a case statement, followed by, you'll notice, a colon, not a semicolon, that will be an expression. This has to be simple. It can only be a fixed value or variable. And then I have a default action. In case nothing matches, then go do this. And another statement that is used is the break statement. So I'll see case matches something, go do item A, do item B, and then when I'm done, break, and that will then exit the switch statement. So the expression or condition within the switch must resolve to a string or an integer. And then you can have within the case those particular fixed items. They can actually be variables as well, which is a little weird if you start using variables for case expressions. But either way, this will resolve down to something that's simple, and it must match that particular item. It's a little more expansive than you have in, say, C or C++, where you can only have a fixed item here, like, say, 17, and it must be a number. So let's look at a simple example of the switch statement. In this case, I can parse something out of an existing handle that I've set up as a word parse. That will return a string, and I'll switch on that particular string. So this becomes my test value. I then have a series of conditions. Assuming that it matches a particular condition, I can then go process. This will call some function. It doesn't really matter. You have a series of code in here. When I'm done and I want to exit the switch, I use the break statement. If this break statement is not here, it will simply fall into the next case. This can sometimes be useful when you're doing particular things, like I may have one condition that runs A, B, and C, and another one that just runs B and C. So I could put the first case above, run A, and then do another case, and then do B and C, which can make some pretty clever ways of organizing things that will make a lot of sense. And then, as mentioned at the very bottom, I can add the default, and the default is, hey, when all else fails, if nothing matches, then go do this. And that operates just like the case, except it simply happens to be when there are no cases that match. And then finally, with these examples, within the structured programming language, I can have an if that has a block. That block can contain more ifs and switches, or I can have a switch case that contains additional switches or additional ifs. So you can get rather complex and rather deep with this. And that concludes part 2 of Program Flow Control. In the next video we'll cover loops. They also have conditions associated with them.